Good morning. A warm welcome to the webinar Process Monitoring with the Industrial DashCam. The principle of a DashCam is, I think, known to everybody, and IMAGO has made the principle ready for the industry. And today, during the webinar, we will learn exactly what the Industrial DashCam is and what we need it for, how it works technically, and we will see a live demo. Our hosts today are Oliver Bartz, our sales manager, and Alkazu Manokov, our R&D manager. My name is Anne Krug, and I will be guiding you through the webinar. We have approximately 45 minutes of presentation, and at the end there will be enough time for your questions. And you can already put all your questions in the chat, and we will come back to as many as possible at the end of the presentation. And with that, I will hand over to my colleague Oliver. Enjoy.
Yeah, thank you, Anna. My name is Oliver Bartz. I'm the sales manager at IMAGO Technologies, and I'm now going to share my screen with you to show you more about IMAGO Technologies, our products, and the idea behind the webcam and its functionality. Let's start with our product portfolio. Who is IMAGO? Basically, our focus is on making computers for the machine vision industry, which go inside a machine. So our typical customers are machine builders who have a machine using vision technology for its functionality. Those machines are, of course, sold worldwide. And as you can see down here on the left-hand side, we built several of our vision boxes named computers in a series production. Those go then into the electronics cabinet of the customer's machine to ensure its functionality. And to be most valuable for our customers, we not only sell standard products, but also vision boxes and smart cameras, which we tweak into the direction of the customer's requirements, creating ODM and OEM versions. Let me show you our embedded vision portfolio. So I mentioned before, we manufacture vision computers. We started more than 20 years ago. Carsten Stramper, our general manager, invented the vision box, at that time based on digital signal processors. Today also with a wide choice of processors, which I will show you on the next slide. Moreover, we have reduced the length between the sensor and the processor, generating smart cameras as well as vision sensors who are capable of either being used with our VoIT framework as well as with your own C++ programming. Let me show you now our embedded computer series. We typically interface with our customers' cameras, standard GG vision cameras, for example. Also faster Ethernet connections are today possible. Camera link is also a standard for using line scan cameras with our customers. That's the camera side. The other side is the machine side. Here we use our real-time communication controller as additional processor inside the vision boxes to combine all signals coming from the machine via digital inputs or, for example, an encoder from a conveyor belt. We use these signals to trigger the camera at the right point in time. We have sometimes LED controllers on board which generate the power for the LED illumination. And then we get the result from the processing, which is done on, for example, an input process. Let's now come to the industrial dashcam, and I would like to show you some use cases where we are convinced that the industrial dashcam will bring a benefit compared to just looking with the naked eye to the machine, especially for those things which you might not be able to see directly because your head is too big to fit inside the machine, but a small camera can be placed at the right position. Typical questions that customers are asking themselves are things like, why is my production line not running as fast as I assume it should be? Is there a problem inside that slows down the process? Or even more impact with a safety sensor that might have stopped the machine before something could be damaged. I have prepared a few examples. So a very classical problem is that your production line is running, and once nothing more happens because the raw material is missing. Why is the raw material missing? So, for example, you can use a library at the input for the material to count your material running into the machine. And if the library is not giving back a signal to the machine and to the DashCam, we could use a heartbeat trigger. Alkazu, our R&D manager, will later explain in a little bit more detail what this means. But we could use a heartbeat from the machine to see, okay, this process is not running any longer, and here the process would be incoming products. So, for example, the robot's gripper might not be adjusted well and might not get every product to place on the conveyor belt, or products might block each other if the guidance is not perfectly aligned. Next example, the machine itself could fail to run smoothly. Typically, in that case, the PLC would output a failure signal, generate an alarm that a person can look into the machine and hopefully see what has happened. But in that case, the person would only see the result of a problem. With a pre-recording, as it happens in dash cams, so you all know the functionality from cars that it records the information before the incident or accident happens. Here we have the same. Before we get the signal, we already have video data available, which is in that case pre-recorded and can be used for the analysis why the machine does not work smoothly. For example, again, a guidance might not work properly, or the timing might be wrong. That is then easy to detect inside the video. Another typical inside machines is that you need to sort out your material that was not processed properly, all the parts which cannot be sent out to customers. And sometimes it might happen that the vision system gives you the correct result. This is a defective part which need to be extracted from the line, and you don't know why, this product is still running on the line. And those failures often happen very, very seldom. Maybe you have that problem every 3 days or so. And typically you can't tell a person to look for 3 days at the production line until this happens, and then think to remember from your brain what this person had seen to understand the problem. Also here we could use the pre-recording to analyze inside the video what has happened. Maybe the machine was not properly adjusted for the next batch. Maybe there are some different parameters that should have been set but didn't, and such things can easily be found inside such a video. Then typically you would need another handling system to pick the material from the conveyor belt back out of the production line, for example, directly into the package. But this picking might fail. And again, the question is, what has happened? When you know that there's a problem, you should know how did it happen. You don't want to restart all the machine process and then find out why all your products are not being picked well and everything is, for example, stocking at the end of the line. So again, here it can be a matter of timing, it can be a matter of positioning, can also be a matter of part dimensions, and that can then be seen in the individual frames inside the video. Last example for now is that if especially the final handling system fails, you might have remaining parts at the end of your line, but you might not have any sensors there to identify that there's something. My colleagues from R&D have programmed what they call an auto trigger to see if something happens in areas that are seen by the dashcam, which means that if products are running inside that area, you would get the recording and then you would get the information why they arrived there. Okay, so we have seen 5 examples. What could be analyzed inside a production line in addition to classical machine vision systems. But what are the key features that you need for this? So I mentioned a few times already, we should be able to record video data before we get the trigger signal to record that data, which means we use a ring buffer inside the industrial dashcam to pre-record video data and only store it to mass media if we want to keep this information. The industrial dashcam is approximately 3 matchboxes in volume, which means you can place it nearly everywhere inside your machine, and you can reach areas and you can watch into areas which you would never reach with your head, and only very complicated using mirrors and other optics. Another point is that with the industrial dashcam, we are much faster than the human eye. So you might recognize some, maybe 10, 20 frames per second with your eye. And you also are not able to really record what you have seen for a longer time. So with an industrial dashcam, you get a much higher speed, more than 50 frames per second. You get a detailed image and you get real data from the real world. In the end, I would also like to tell that here we have the fastest industrial dashcam on the market already. So using IMAGO technologies means you're at the top of speed. And now I would like to hand over to Alkazu, our R&D manager, to tell you a little bit more about the operation of the industrial dashcam.
Hello everyone. Just a second. Okay. I'm Alkazur Monakov. I'm the R&D manager at IMAGO Technologies. All the devices that you see, including all the products, IMAGO products, are developed here at IMAGO under my supervision. As Oliver already mentioned, human eye is very limited from many points of view as an instrument for debugging a machine. Therefore, it is sometimes useful to use an industrial dashcam. Oliver has already mentioned its main features. I will introduce the dashcam versions. After that, I present the different ways the dashcam can capture the videos. We take a look at the resolution and it's the FPS, so the speed. They are interrelation. We consider the triggering. We have a look at the web GUI, and finally we check how does it look like in reality and have a live. The industrial dashcam has two versions, or counts in two versions, with the M12 objective lens. As you can see, it's more compact, or but then the choice of the objective lens is limited. Alternatively, you can get a C-mount version. There, the choice of objective lenses is larger, and you can adapt it for your application. You can again choose whether you want to have an integrated lighting or you do not. Also a valid option. And okay, choosing the lens obviously for the M12 version is a little bit more difficult because it has to fit into the housing. Therefore, there is a C-mount version. Well, natively, the sensor allows to capture full HD video with 60 FPS. Obviously, in color and mono, you can choose whatever you like, whatever your application requires. By setting region of interest, you can influence the FPS, the frames per second, which it takes. I mean, 60 FPS is already much faster than the human eye, so you will be able to resolve the motion in a very precise manner, or in a more precise than the human eye would. But if you want even more, you can choose the resolution, the region of interest, and increase the FPS. There is an interesting feature that the sensor has. It actually, the region of interest, it doesn't matter if you have it. It doesn't matter how many columns do you have. It's rather more important how many rows do you have. So like if you reduce the number of rows, the FPS goes up. So this is something interesting when you want to capture the fast motion. Okay. Well, the video is recorded around the trigger and or the trigger moment, and different applications require different moments, trigger moments, and you can choose it freely. I mean, you can, let's say we fix the length of the video. Let's say it's 20 seconds, yes. And some applications would require that you record the video before the trigger moment. And in this case, some applications would require that after. In this case, it's balanced. It's a little bit in the past, it's here in gray, and in the future. This models the case where, for instance, I don't know, let's say at the trigger moment, the machine stops, and you want to understand why did it stop. Therefore, you capture the video before the trigger moment, and then you want to also observe how the stopping the machine, the transfer process develops. Yes, so how is it stopping, or how the situation is developing. Yes, so therefore you probably want to take a little bit of a video in the future. There are another kinds of applications where you probably want to, oops, you probably want to rather shift it into the future. Like this would be something like, okay, I want to see what happens when I start my machine. So it gets the signal, it starts the recording with the start of the machine, and then the machine, when the machine, let's say, arrived to the certain or reached the certain speed, you stop it, and then you analyze how the machine was starting. Okay, another applications, for instance, there are another kind of applications require the focus to be shifted, let's say in the past, meaning that, I don't know, let's say a screw falls into the machine, yes, and the machine stops, but you never know why the machine has stopped. So you see, you want to see the screw, so it needs to know, you want to know what happened before. How does it work? It's simply the video is captured in the ring buffer, and then in the memory, and then when the trigger moment comes, it saves the video onto the SD card or another storage media. Let's talk a little bit more about the trigger. What are the trigger options that DashCam has, and how to use them? So the first is obviously the hardware trigger. So all of the triggers actually only choose the moment, or the trigger moment, okay? So in this sense, they are all the same. The only difference is the interface, how this trigger moment is communicated to the industrial dashcam. So the hardware trigger, it's a very simple and very intuitive thing. It's simply a digital signal which industrial dashcam receives. It has two inputs and can receive it over one or another. The second one is heartbeat mode, where basically the dashcam saves the video once the heartbeat is gone. Let's say your machine is producing some the heartbeat of certain frequency, and if heartbeat has disappeared for a moment, let's say an error happened or an alarm or something like that, or machine is not responding anymore, or the controller is not responding anymore, PLC, then the camera will save, let's say, the video of last 20 seconds or so. There is a software trigger, just a button in the web GUI, which I'll show you, which triggers the recording of the video or the saving of the video. And there is an auto trigger, which is based on the image processing, so the camera can trigger itself just by, let's imagine something very simple. You're expecting only white objects, and there is suddenly a black one. By just analyzing a small area, you'd be able to tell and save the video just to analyze why did it happen? Why is the black object there? Okay. All the controls of the webcam, of the dashcam, are made via the web GUI. One can set all the parameters, the acquisition parameters, the dashcam parameters, the length of the video, how it's distributed between the past and the future. One can choose the trigger, how the things are triggered. One can watch the videos. One can watch the videos frame by frame. You can download and delete the videos, so it's the management of the videos is also implemented. And now we are ready for a live demo. Almost. Web GUI also allows to give the camera a name, dashcam name, so that if you have several dashcams in the machine, you know at which machine you are looking at. You can store videos remotely or like on some remote server or directly on the DashCam. You can pull the videos via an FTP, for instance. And for integrating the camera into your machine, there is the REST API. Yes, then you could, for instance, integrate the functionality or the control of the dashcam into your graphical user interface. Now it's the time for the live demo. Oh, I closed the tab. Let me look the camera up in the net. It's this one. Okay. Let's start the acquisition. Oh, it's a little bit dark. I will just adjust a little border time. Too much, sorry. Okay. Now, I will switch off the auto triggering because it keeps. Okay. Let's have a look. What do we have here? I mean, the whole view doesn't fit into my screen. I will make it a little bit smaller, like that. Okay. So now it's at the full resolution. Let's have a look. What is the FPS that we are getting? The maximum. 71. Okay. Probably not the maximum, but okay. Let's try to reduce the region of interest to the point we are interested in. Some action into the scene, like that. Okay. Close the chat. Okay. That. Oh, too much. Like that. Okay. Now let's see if we can get more FPS with that option. Yes. Okay, so that sounds better. Okay. Now I will use a digital trigger to save the video. Let's have a look. What did I set up? If it's the past or the future. Okay, it's equally distributed into the past and the future. I will just reduce the length so that we can watch it then faster. Okay. Start. Okay, so now it's taking. I'll trigger. I use a digital. Okay, so it's saving the videos. Sorry, the signal is not debounced, therefore it saved 2 videos probably. Just let me see. Let's have a look. What did it take? Load. Okay, so these were the 3 seconds. Let's try to watch it frame by frame. Takes a little bit of time to disassemble a video into frames. Okay. Okay, so what we have is we can switch the frames or choose the time. So these are the 3 seconds. We can from here download the video, for instance. Okay, now let's delete the videos we have and take a new one, but now let's activate the auto trigger. We just do the bias. Okay, so the bias means how much is there is a difference. Like we are looking at the white paper and expecting it to trigger on the black paper, but not on the gray paper, then we should increase this number. I will decrease it a little bit so that it reacts to my hand. And so this is a part of the area which is changing. So it's 20% of the area. Seems okay. I just say use, and let's see if I can trigger it. Yes, I can trigger the thing. This is good. So let's see what did we record. Okay. Did it take only the future or the past? Okay, it's mostly taking the future after the trigger moment, which makes sense. Okay. Okay. Now, if there are any, so all the events, the things that you do with the DashCam are here in the log. You can watch it. If there is any error or like you set something wrong, anything like that, which normally is not allowed, but if there are any errors, they will, or warnings, they will be printed here. You can change the theme if you like the darker more or the brighter more. My DashCam is black and white, but there is a color versions. Let's try to shift the trigger area, let's say, to this point. Maybe let's make it a little bit more to this point. I just set trigger region. Okay, or we can make it a little bit bigger, like that. Okay, let's see if it triggers. Yes, it triggers. Saves the video. You can control, so that my DashCam has an integrated light. I can switch it on and off just from here. Obviously, all the functionality that is available in the web GUI also available in the REST API, so that you can integrate it into your GUI. With that, I thank you for attention, and I hand over to our host, Anna. Anna?
Yeah. So, good morning, everybody. I had some technical problems in the beginning. My name is Anne Krug, and I will be guiding us through the Q&A session today. And when you have any questions, just put them in the chat box, and we will try to get back to as many of them as possible. And I have a first question. What do I need to start?
The answer is pretty simple. So the industrial DashCam is ready to use, which means it comes already as a complete system. Let me show it. You just connect to those M12 connectors, your power and your Ethernet, and can directly start using any web browser, which means you just need to find, as Alkazu showed, the industrial DashCam in the network and open the GUI window. If you don't have these M12 cabling already available, we also have a starter kit to bring the 24 volts to 230 volt for a lab as well as bring the M12 gigabit Ethernet connector to an RG45 connector that you can plug into your typical Ethernet sockets.
Okay, the next question. While reviewing the captured video, would it be possible to see only the differences in the pictures without that what is always in the picture or video? In that way, it would be possible to focus on the changes. I will repeat the question. While reviewing the captured video, would it be possible to see only the differences in the pictures without that what is always in the picture or in the videos? In that way, it would be possible to focus on the changes.
Yes, I understand the question. Right now, this functionality is not foreseen. Maybe I mean, I do not know what are the changes that you are talking about, but probably these are related to the brightness changes. Maybe you want to have a look at our other product, which is VisionCam EB or event-based. It detects only the brightness changes. So this might be a solution.
Yeah, please feel free to contact Oliver with that precise question. We have a good product for that only sees the changes in the scene, that only computes the changes in the scene. Another question, there is no is there any processing tool on board?
This is a tricky question because one can understand it in many different ways. I mean, video compression is somewhat okay. Now Giorgio has specified what he means. So currently he talks about the image processing, like whether we can process the images that the camera stores. So right now not. It only stores compressed image sequences in terms of videos.
Next question, where are the video files stored?
Alcazar, do you want to answer or shall I?
No, I will. Okay, so by default, the user can choose where the videos are to be stored. You can store them. Okay, let's say there are many possibilities. Okay, so you can store them on the SD card. If your camera doesn't take so many videos per day, then this is an option. Otherwise, let's say if it takes a video every minute, this is not an option. You can simply quickly write the SD card dead. So in this case, we would suggest to write onto a remote directory, let's say via Samba protocol. Another option which we have is to write the videos onto the RAM directory or RAM partition. And okay, it will not be, this partition then is limited by the size of the RAM of the DashCam. But if there is a FTP client which pulls the videos regularly, it will probably be okay. So there are many options. It depends on the application.
And a question that is closely related, what are the capacity limits of the camera?
Okay, so currently the camera is delivered with 32 gigabyte SD card. part of it is used for the operation system, so the user has about 30 gigabytes for the videos, which is several weeks. Several weeks. It's several hours of video, but if the video is not taken every minute, but let's say every hour, then it stretches to several weeks. Now, but it doesn't mean that you need to do a regular servicing of the camera, because let's say if the card is full, you can set up the limit, by the way. What does it mean full? If it's at 80% or 50% or whatever, then the videos, the old videos, will be overwritten by the new ones. So it's not, it doesn't stop functioning.
Mm-hmm. And next question, what is the RAM size in seconds, in full resolution and max speed? What is the RAM size in seconds, in full resolution and max speed?
Okay, we probably are talking about the video size. It's about 20 megs at full resolution, full speed. If you reduce the region of interest and increase the frame rate, so the data rate will approximately be the same. You can also play with the encoder bitrate to meet your needs and to use the RAM efficiently. The device, I think the RAM size is in this sense irrelevant. The video length is currently limited to 20 seconds.
Yeah. And this 20 seconds are around 50 megabytes at full resolution and standard settings.
Okay, next question. Can I control several dash cams simultaneously?
Yes, you can. The cameras have the REST API for control. So if you are integrating several dash cams into a GUI and you want them to behave similarly, then you're just sending the API, the REST commands, the REST API commands to several cameras. I would say simultaneously, but it's not quite true. So they would, with a very small delay, and they will be controlled simultaneously.
Mm-hmm. A question that goes into the same direction of the question that already was asked, but nevertheless, I will ask it again. What happens if the card is full?
The videos are on the DashCam are saved into or are managed as a ring buffer. Therefore, all the videos will be overwritten with the newer videos. So the size, so how much the ring buffer should occupy on the SD card, can be decided by the user.
Mm-hmm. We have one last question about the delivery date.
Oh, that's pretty easy to answer. So at the moment, we have all material in stock to manufacture the monochrome version. And due to delay with our supplier for the color sensor, the color version will become available in May, around May.
Mm-hmm. So if there is no other question left, I want to thank you all for attending the webinar. It was a pleasure of having you here. And after the webinar, you every participant will get the presentation deck as well as the video recording. And if there is any question that has been left out, don't hesitate to contact Oliver. He will get back to you as soon as possible. Thank you very much and have a nice day. Bye-bye.
Thank you as well. Bye-bye.